Okay, we come to the last question for question 10. This question 10, right, is somewhat similar to the rock sugar experiment. Okay, so I have this copper sulfide crystals. It's a kind of compound. It's a crystals. Okay, it's very beautiful, and it can dissolve in water to form a solution. That means it completely dissolve, just like salt with water. But just like now, we are not using salt. We are using this copper sulfide. So dissolve in water to form a solution. And this experiment was carried out to investigate the rate of dissolving, okay, in various conditions. So you can see from the table, I got 5 experiments here, and the water I use are of different temperature. And then I have some fine powder of the copper sulfide crystal. Sometimes I use big pieces. Okay, you have to read yourself the different experiment. And then I record the time taken for my crystals to dissolve. How much time is required for them to dissolve completely? So what variables should be kept constant in these experiments? Okay, in fact, right, the rate of stirring, okay, the mass of the copper sulfate crystal used, okay, the volume of water used must be the same. Okay, okay, the variables should be kept constant, right? From part B, from the data, which cell experiment should you choose to test the following hypothesis? Part 1. The smaller the particle size, the faster the rate of dissolving. So in this case, right, I'm obviously trying to find out the size. How does the size affect my rate of dissolving? So I should choose either experiment 1 and 2. Can you see? The temperature is the same, but I use one big piece, one small piece. Or I can choose experiment 3 and 4. Temperature is the same, one small piece, one big piece. Okay, so I can as I compare lah. Okay. Then part two, I want to find out temperature. So in this case, right, the size must be the same, but the temperature must be different. So I can compare experiment 1, 3, and 5. Okay. So you can see temperature, experiment 1, the temperature is 30. Experiment 3, the temperature is 40. Experiment 5, the temperature is 5. But the 3 experiment, 1, 3, and 5, right, all of them are using fine powder. Okay, I can choose experiment 2 and 4. You see 2 and 4, the temperature different, but I'm using big pieces. Okay, so it's really depending on how you want to carry out experiment. Okay, we're left with part C now. Okay, part C, um, we talk about solubility. The maximum mass of solute that can dissolve in 100 gram of water. Okay, so the maximum amount of solute that can dissolve in 100 gram water. So the temperature is again like that. Okay. Okay, which two experiments show that solubility is not affected by the not affected by particle size of copper sulfide crystals? Okay, it's experiment A and B. Why? Okay, experiment A and B is the temperature the same. Okay, uh, okay, the size. This is the maximum amount of solute that can dissolve. And you realize, I see, even though I use fine or big pieces, it doesn't really matter. The same amount of solute that can dissolve is still the same. So that means the powder, right, whether it's a big piece or small piece, but the actual amount that can dissolve doesn't matter. Whether it's a fine piece or big piece doesn't matter. Okay. Which variable shown in the table must be held constant for the above observation in part 1? Okay, obviously temperature must be the same, otherwise we bias, no? Because if I use a higher temperature, I will be able to dissolve more of the um, copper sulfide crystals because temperature will affect the stability, how much can actually dissolve, how much. So solubility is talking about how much the solute, the crystal can dissolve. Okay, that's it for question 10. Please take note, solubility and rate of dissolving, they are different. Rate of dissolving will involve time taken. All right.